Hello, welcome to this video on lesson 1-3, intercept symmetry, even and odd, and intersections. In this video, I'm only going to talk about intercepts and symmetry. I'm going to split it up. And then in videos 2, we'll talk about even odd functions. And then video 3 will be a calculator video on intersections. Remember, the objective of this video is to find intercepts. And we kind of talked about this in the last lesson about finding zeros, but to find intercepts, remember, they need to be represented as an ordered pair. So just some notes, and x-intercepts are points where the graph crosses the x-axis, and so therefore your y-coordinate is 0. So in order to find an x-intercept, again, we just plug in 0 for y. Now, y-intercepts work just the same way. These are points where the graph crosses the y-axis, so our x value is going to be 0. So all we have here is just pure substitution. So example 1, it says find the x and the y intercepts for this equation, y squared minus 3 is equal to x. So again, we're going to go ahead, we'll find the x-intercept, and for an x-intercept, you just plug in 0 for y. So I have 0 squared minus 3, which gives me equals x. Okay, so we get x is equal to -3, right? And to write it as an ordered pair, right, because they want to intercept, not a 0, we would say this is -3, 0. Okay, to find the y-intercept, we're going to do the same thing, but we're going to flip it, right? I want to make x 0. So we get y squared minus 3 is equal to 0. Okay, so I plug in 0, and we solve. Y squared is equal to +3. Y is equal to plus or minus √3. Okay, so here we have 2 intercepts, right? And the intercept would be 0 square root of 3 and 0 -√3. Okay, so those are our intercepts. Easy enough, right? Just plug in 0 for y to find your x-intercept, and plug in 0 for x to find your y-intercept. Okay, the next topic we're going to talk about is symmetry. Okay, and symmetry, right, is just a mirror image. And if we have y-axis symmetry, we're going to have a mirror image across our y-axis. If we have x-axis symmetry, we're going to have symmetry across our x-axis. It's going to be reflected. We also have a third type of symmetry called origin symmetry, and this reflects through 0, 0, and all points will be on either side, right, of the origin will be equidistant. So here's some visual examples of these types of symmetry. Okay, so what we have here are formal tests and informal tests for symmetry. In this video, we're going to start out with informal tests, and then we'll go to the formal test to show these. Okay, so I'll start out here with y-axis symmetry. Okay, we want to substitute a number and its opposite for x, and we should get the same y value. Okay, so once we have an idea, we'll go ahead and do the formal test. So how's this proven formally for y-axis symmetry? Well, we replace x with -x, right, and we get the same equation, right? And that makes sense. You should have, again, points, right, x and -x, that have the same y value. That's y-axis symmetry. Okay, for x-axis symmetry, we substitute in a number and its opposite for y, okay, and we get the same x value. Okay, so formally, that is replacing y with -y, okay, and we get the same x value, okay, and that's shown here, right? So same x value, the different y values have the same x value. Okay, and again, remember that this would not pass the horizontal line test. Okay, so this would definitely not be a one-to-one function. Here, the last one that we're going to talk about is a origin symmetry, okay? And this is found by substituting a number and its opposite for x, and you get the opposite y value, okay? So formally, I'm going to plug in x and negative x and y with negative y, and I should get the same exact equation. All right, so let's look at some examples about how we're going to plug these in. Okay, so here are our 3 examples. And I'm going to start out again, remember, with informal. So informal. Okay, and a nice number to always plug in is 1 and 0. For proving symmetry, you want to stay away from 0 because sometimes you can't see the symmetry, right? So we'll go with 1. I'm going to plug in x equals 1. And if I plug in 1, I get y equals 1. Okay, that's my output, right? 1 cubed is 1 times 2 is 2. Take away 1, we get 1. Okay, now what I'm going to do is I'm going to plug in the opposite. I'm going to plug in negative 1. Okay, and when I do this, I get y equals negative 1, right? Negative 1 cubed is negative 1 times 2. Negative 2 times, take away negative 1, right? Which makes it a plus 1, so we get negative 1. Okay, so this is looking like origin symmetry. Okay, so what I'll do, now we'll go to the formal test. Okay, so I'll plug in negative x, so 2 times negative x cubed minus negative x. And what this gives us is negative 2x cubed plus x. Okay, now to see the symmetry, what I'm going to do is we're going to factor out a negative, and we get 2x cubed minus x, right? And if we look here, that is just y. So if I plug in negative x, what we get is negative y. So this is origin symmetry. Okay. Example 2. We'll go ahead, we'll do the same thing here. I'm going to do an informal test first. Okay, and I'm going to plug in 1. So x is equal to 1. Well, 1 take away 2, this gives us y equals negative 1. Okay, and then I'll plug in the opposite x. And what I get is the absolute value of negative 1 is positive 1. Take away 2 is negative 1. So we have opposite x values, which produce the same y value. Same y value with opposite x values. That looks like y-axis symmetry. And again, now we'll go to the formal test. Okay, I'm going to plug in the opposite x. So I have the absolute value of negative x minus 2. Well, this turns positive, right? Your absolute value turns positive. So we have absolute value of x minus 2, which is our y. Okay, so this is y-axis symmetry. All right, and then for our third one, okay, I have the absolute value of y, and just kind of thinking about the absolute value, right? You're gonna have symmetry, okay, and if it's the absolute value of x, right? If we take the absolute value of x, you get a graph that looks something like this. So notice the absolute value here is of y. Okay, of y. And that should look something like this. So I'm leaning towards x-axis symmetry. And so what I'll do, again, we'll do informal. Okay, and I'm going to get, let's plug in x equals 3. I'm just going to show you with the x value. So if I do this, we get the absolute value of y is equal to 1, which means that y is equal to plus or minus 1. Okay, so we get two y outputs. Okay, so this is leaning towards y-axis symmetry. Now we'll do the formal test. Okay, and the formal test says plug in the opposite value of y and you should get the same equation. So if I plug in the absolute value of negative y equals x minus 2, this just gives me y is equal to x minus 2, and we have x-axis symmetry. Okay, so that is symmetry. Again, remember in this video, our objective was to be able to identify symmetry in different types of graphs, as well as identify intercepts.